Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show, bringing you another really awesome guest today involved in creating a better tomorrow. Today, we have the honor of being joined by Dr. Raj Yavatkar, who is Chief Technology Officer at Juniper Networks, where he has broad responsibility for charting their company's technology strategy, leading and executing on their critical innovations and product for intelligent self-driving networks, security, mobile edge cloud computing, as well as network virtualization and packet optical integration along with other technologies like hybrid cloud. A technology and products pioneer across his career, Dr. Yavatkar has envisioned ultimately how emerging technologies can be applied to creatively solve problems, enterprise and business problems ahead of their competitors to establish various new product lines. Before joining Juniper, he was at Google. They're leading a large team of engineers to develop cloud networking infrastructure and products for Google Cloud. Prior to that, at VMware, developing new product concepts to address the private hybrid cloud market, leading to large product teams to deliver various new products in that area. And he started his career at Intel, rising to the position of Intel Fellow, position he held there for 10 years. And during these various leadership roles, Dr. Yavatkar was responsible for driving new product and R&D initiatives in many areas of software, bringing a wealth of experience in emerging technologies, has dozens of patents, over 60 research papers, co-authored a book on internet quality of service, and is also an Institute of Electrical and Electronics Engineer Fellow, holding a Ph.D. in computer sciences from Purdue University. A lot to talk about today, a lot of topics we don't normally get into. Excited about the episode. Dr. Raj Yavatkar, thank you so much for taking the time to come on the show.
Thank you, and thanks for the nice introduction.
Yeah, I really look forward to our discussion today. Again, topics that we don't normally get into, but would love to start off back at Purdue University. If we could take a little time travel back to 1989. I took a look at your PhD, as I do for most of our guests, and yours is entitled "An Architecture for High-Speed Packet Switch Networks," which here we are in 2024, able to zap around movies in microseconds and things like that. Things a little different in 1989, but we'd love to hear about how this all got started in thinking about how to move things around on these networks back in the late 80s.
Sure, I think I worked with Professor Doug Comer, who was one of the members of the so-called Internet Architecture Board, which basically decided the architecture of the Internet, how it should evolve. And this was before the HTTP web browser days. So Internet was used mostly for emails and maybe some beginning of audio conferencing and stuff like that. And it was restricted largely to academia and some companies such as defense contractors like BBN, Sun Microsystems, and AT&T, and so on. So one of the projects I worked on as a research assistant was called Cypress Network, which was the first network nationwide created in academia before NSFNet, which used 9600 baud lines to with simple workstations as packet switches to connect the network across the country, starting from Boston all the way to California, in Midwest, and so on. And out of that came the thesis idea that how would the evolution of the network happen and what is required to go to higher speed packet switching. So I used off-the-shelf LSI 11 microprocessors to build this multiprocessor packet switch, which could scale. I actually built it with implementation. And the idea was to be able to show that you can scale the internet speed. Of course, as you said, now we are at a very different speed, and that time it was a very different era. But the idea was to define the architecture for these packet switch networks along 3 dimensions. What will each of the packet switch scale? How will it scale to higher speed using multiprocessors, using all software implementations, and nothing in the hardware? Second was, as part of my thesis, I'm proud to say that I was one of the people who introduced the term flow that's using very commonly today. It was introduced in a paper I published in '89 in Infocom. The flow basically says that rather than looking at packets going from one machine to another, look at the applications. And application traffic is identified by so-called these 5 things: the port as well as machine address. And I called it a flow because a bunch of packets going from one place to another but belonging to a particular application should be separate from another application. The reason for that is, if you're doing video streaming, you're going to have different characteristics in that flow versus, say, you're sending some audio traffic or you're sending just some file transfer and so on, right? And part of the thesis was also to look at what sort of congestion management and flow management techniques you'll need in the network so you can guarantee certain quality of service. For audio traffic, which requires low latency, mostly you want to deliver audio packets in 250 milliseconds or so before you start noticing gaps in the conversation. Video, you want bigger flows. You want them to be delivered, and sometimes delivering out of order or losing some packets is okay. And a file transfer is another example where you need to do large file transfers in a reliable way. You are willing to retransmit and all. So how to distinguish between them? So congestion management, flow management was the second part of the thesis. And the third part was that how you stitch together this from management perspective, right? How do you bring all these pieces together? So that was good. I think looking back, some of the things are still relevant, but some of the things, of course, we have evolved way faster than we imagined.
And another interesting one that stood out to me as I was going through your extensive publications was this piece. This was in 2011. I think you were at Intel at the time, and this was an IEEE Symposium on Computers and Communications entitled "Detecting Non-Transient Anomalies in Visual Information Using Neural Networks." And again, we see the AI, the computer vision in this particular case, looking at really cool things like, hey, who leaves this bag unattended at an airport? Who's writing graffiti on that wall? Again, we'll be talking about AI in a bit and sort of where we're going, but talk a little bit about AI, machine learning, and sort of, in this case, computer vision that started to seep into your work around this time.
Yeah, so I have had the fortune to work with really, really smart people in my career, right? So when I was at Intel, I used to work with Professor Andrew Campbell, who was at Columbia University, and his students. So one of his students came in to work with me as a summer intern, and I hired him after his PhD. Michael Kunavis, I would say he's more of a Greek mathematician than engineer, a very smart guy. And this particular paper, he's the first author. This was a joint work we did. So if you look at that time, the video processing was in vogue, like a lot of surveillance cameras were coming into picture to be able to address security issues. But if you look at the video stream coming in at an airport or a shopping mall or something like that, there are lots of motions happening, but they are not of interest. Like you said, if somebody leaves a backpack at the airport, that's a sign of concern. And that's an example of non-transient anomaly in the sense that it's not going away. It's left there. It was not there 24 hours back, right? So it's something new happened. To be able to detect those fast way while processing so much video information is very hard. So the idea here was to only focus on, first of all, do tiles of the video, tile it into different small images, and only look for, based on the time series analysis, what is changed and remains changed for a long time. So you can focus on those. And that becomes very fast, and we are able to show that this scales when you're getting multiple video streams in a very busy intersection or airport or any such things. So that was the work, but I give Michael the credit because he was the real mathematician behind it.
Really cool, nonetheless. And again, just I wanted to set that all up, of course, based on where we're going to be going with AI and networking in a little bit. But Raj, I was wondering if you could take a little time and, talk a little bit about Juniper and its history. And it's funny because, 20 some odd years ago, where I was sort of entering my career and going into the pharmaceutical industry, I had a really good friend that went to Wall Street. And he was an IT guy, and all he could talk about at the time was this emerging company called Juniper Networks, which I never heard of. But he said, this is the coolest thing. You're probably not going to hear a lot about them, but and here we are, 2024, close to 10,000 employees, 50 countries, billions in revenue. We don't hear a lot about you all the time, but obviously you're behind the scenes on some of the most important aspects of everything that's going on our computers and networks nowadays. Talk a little bit about the evolution of the company, if you would, and a little bit of, as you've been there, the evolution that you've seen over the years in its model.
I was also a big fan of Pradeep Sindhu, who was a founder of this company. And you have to look at the history. The company started as a disruptor, an innovator. So that time people were building routers using Intel-based PCs kind of devices. And if you look at the late 90s, the dot-com boom created internet being used first time for really consumer commercial ways, right? Because of HTTP web browser and all. So amount of traffic in the network was literally doubling every 6 months. And using traditional computer processor like Intel-based processor to do routing was not sustainable. So this idea Juniper came up with is have a custom chip which is designed for packet processing. And the first router, the M40, provided performance or throughput an order of magnitude higher than what was possible that time. And it followed up with creating this series of products. And that's how the company grew, then moved into network security. And that network security now, you see other companies formed out of Juniper, where they left Juniper, but the Juniper, like Palo Alto Networks, Fortinet, these companies came out of Juniper, right? So Juniper continued that path and then also got into enterprise networking and so on. The biggest change that happened ahead of the industry recently is 2019, when Juniper acquired this company called Mist.ai. Mist.ai is a company which was applying to Wi-Fi networks first time, very different approach than managing wireless networks. They said we are just going to have access points. You see all over in the building anytime you see Wi-Fi network on premises, and they will be connected to the cloud. Everything will be managed from the cloud, and we'll collect data from the network continuously, and that data will feed into machine learning algorithms to be able to do automated root cause diagnostics, being able to tell there's a problem exists before even user knows there's a problem in the network, and correct it. And that approach, now everybody's talking about applying machine learning to networking, but Juniper pioneered that with Mist long time back and started extending that all over the network. Now we have about 7 years of data from the network collected, trained models, which we can apply to wireless networks, campus branch networks, access networks, data center networks, and WAN routing. So that's a big advantage we have, and that's what led to some extent acquisition by HP Enterprise of Juniper for networking differentiation.
And that's a great segue here because obviously you relayed the groundwork. We're in an era of AI, generative AI, machine learning. We hear everything about the GPUs and the servers. Clearly, AI and everything you were just describing has its role in the invisible, everything that happens all above us in the cloud that we don't see, but moving around. Introduce us a little bit to this principle. I mentioned it in your bio, but if you could walk us through, because I think this is core to what you're just talking about, the self-driving network, what that means, and what, this combination of flow, as you're talking about, machine learning, telemetry, all these terms ultimately come together in this concept, because I think this is a really important piece of what's happening at Juniper.
Sure. So let me start with a simple example. You are on iPhone or iPad, connected to a Wi-Fi network, right? And many times people start seeing slower performance, or my Zoom call has a glitch and so on, right? And traditional method is then you file a troubleshooting ticket if you're in a corporate environment, then somebody from IT takes a look at it, they contact you, they try to find the problem is, they fix it. Hours might go by. But imagine instead of doing that, my device is every 5 seconds or every second, whatever interval you choose, sending information about the experience I'm seeing on the network side on my device in terms of applications or anything. That data is going to the cloud. And based on that data and all the other data being collected from other devices, as well as in the network itself you're getting data from, you start correlating. And machine learning is very good at taking large amount of data and finding patterns very easily automatically. You can train models to do that. So if you train the model now, when my iPad starts seeing a glitch, it already finds out what the problem is. Problem is because maybe that inside the network to which I'm connected, that switch is having a problem. It's running out of buffer space, or the packets are getting overrun. Then if I know the reason, I can start also taking automated action. I can say, or maybe I should reroute this traffic around this switch, right? Or maybe I add some more capacity, whatever I can do, so that problem is not only diagnosed, but alleviated, resolved. That's the basic concept behind self-driving network. Network is full of sometimes tens of devices, hundreds of devices. They're all interconnected to let the traffic go from one endpoint, like my iPhone, to a cloud where I might be using Gmail or Google Drive or some application like that. All that path, if I have data, telemetry collected, and I use this constantly to do correlation, use machine learning algorithms, then I am able to find anomalies, which are the problems, find the root cause for them, and be able to fix them in an automated manner. And this has happened to us, that publicly some of our customers, and some Fortune 10 companies are our customers, all Fortune 10 companies, they have publicly stated that once they started using our solution, Mist-based, this AIOps solution, 90% of the troubleshooting tickets are self-resolved. That's an example of self-driving network.
And we'll talk about, you know, all of the tools that are being developed and go into Juniper beyond in a minute. But could you mention, I mean, there's a lot of pieces that make up the self-driving networks, like, and I'll just list some of the ones that are, you have the RAN intelligent controllers, the Open RAN service management orchestration solutions, the cloud native routing. Without you having, you know, obviously we'll put a link to the website with regard to all these services and tools, but you could sort of give us a little summary about sort of what the technological direction evolution is here in creating, you know, I guess the next generations of these self-driving networks, because they're clearly, based on everything we're saying, clearly they're quietly in control, doing all the things that we had people doing in the past, and now, you know, they're taking care of most of that. Talk a little bit about some of these tools that sort of are encompassed within the umbrella of the self-driving network.
So I think the self-driving networks is an evolving concept. We are going to learn continuously. So when I step back and look at this from my role as a CTO, we came up with this concept of path finding innovation, which is basically says that how can we continuously create a system by which multiple people can come up with ideas. That's funnel of ideas. We funnel them into some kind of a path finding effort where we can quickly try out the ideas, see which ones are likely to yield some good results or give good impact, and then incubate new software products to add to the current portfolio of products. That's a pathfinding concept, and we have been driving it. And the ideas come from everybody. They can come from sales engineers, marketing, product management, engineers, everywhere they can come from. So part of that is we really created 4 pillars for this. One is artificial intelligence, machine learning, which is very much into the self-driving networks you mentioned. The second one is sustainability, because, you know, we have to be good corporate citizens, but not only responsible, it makes business sense to be sustainable in our practices, how our products are used by customers and so on. Third is quantum networking. The world is going to go to quantum computing and quantum networking. People say it will happen in 10 years, some people say 5 years, but we have to find what is real and what can be used. And lastly, 5G. Why 5G? Because the internet has evolved now. No longer the internet is about sitting in the middle of some big network. All of the traffic is mostly driven by mobile internet. So 5G and its evolution is very important. So those are the 4 pillars. So let me go through each one of those. So let's start with AI/ML. In AI/ML, our thesis is that self-driving networks will go to the point where they are aware of end users and end applications. I call it application-aware assurance. I want to provide you assured service experience, which means you not only get the connectivity, but you also get assured service experience with respect to the performance you see, security you see, and performance in terms of latency, throughput, and so on. So we have been evolving the machine learning models to be able to collect data from everywhere in the network, not just network, but applications and what they see, and start correlating across all of these parts in the application stack, if you could call it, and apply machine learning to do correlations actively to be able to provide guaranteed service experience, right? The second is sustainability. As we do products, it's important to know that the networks today are designed, and systems we design like routers, switches, are over-engineered. We design them so that my product meets requirements of this customer versus that customer versus that customers. Even the one customer comes from enterprise, another comes from AT&T like service provider network, another comes from the cloud customer like Amazon. So when you over-engineer these products and deploy them, they use more energy than necessary because only a subset of the features are being used. So we came up with a mechanism by which we can say in a running network, in a particular customer, we can turn off the features, turn off the parts of the devices so that we can save power. Secondly, the customers also over-engineer their networks. Why? They want to be ready when the peak capacity is being used. In the middle of the day or some, if you're our network provider to a stadium and suddenly the stadium area, suddenly the 5G network goes up because there's a football game happening. So networks are also over-engineered. So what we do now is that we do thermal and power profiling of the network as it is running. And based on that, based on utilization, we can turn off the parts of the network, parts of our devices, parts of switches. So rather than using 4 different parts, you can use in one part because the utilization is only 10%. So that's a sustainable network. So that's the second pillar. And the third one, as I said earlier, is really looking at quantum computing, quantum networking, its evolution. So what we have done, that we found that one of the biggest problems in the network is when you use security like IPsec tunnels. So you people use VPNs. They are very familiar with that. We do what is known as symmetric key exchange. Both the parties have to agree upon what the keys they are going to use to encrypt the traffic so we can send encrypted traffic. And that is prone to attacks now. If quantum computers get more and more powerful, they can break those keys. So quantum key distribution is a new part of quantum networking where you add some more secrets to exchange between the two people who are trying to do secure connection, but they do outer band using quantum channel. So there are startups who have come up with these quantum channels. So we worked with them and we have a product now for IPsec VPN tunnels, which is shipping, which does quantum key distribution to protect against key breaking when the quantum computing becomes real. And quantum computing is becoming real slowly. Now people are in Wall Street are using some of our financial services quantum computers. They're probably 1,000 qubits or so, not big, but they're still practical and being deployed. So it's important to start looking at this evolution and not wait for it to start disrupting our networking industry, but start taking mechanisms like quantum key distribution. And lastly, as I said, 5G. This is about what you mentioned, RAN intelligence controller. The 5G networks, because of geopolitical reasons and all, there are only 2 vendors who are providing products for that, which is bad for the customers because the prices go up, there's not much choice. So this new initiative that our customers started, our telcos, it's called Open RAN Alliance, Open Radio Access Network, and we developed what we call the operating system for that, which is a completely open operating system like, how you use Windows or Linux. Anybody can write applications on top of Windows, right? Anybody can have Windows running on any of their platform. It could be ARM-based, Intel x86 based, and so on. Same idea, our rig can run as an operating system for the network, supporting radios from anybody, any vendor. Also, as third-party people can write applications to optimize the network, to make it more energy efficient, to make it more secure, provide guaranteed service for different slices. Those kind of things we are doing in that area. So those are the 4 pillars by which we are driving our vision of self-driving networks on using these multiple pillars.
And everything you just mentioned, from the 5G to the AI, to the quantum encryption, to the sustainability of the networks, ultimately all of these ideas, these innovations, come from something that you've developed there known as Juniper Beyond or Juniper Beyond Labs.
Labs, yeah.
You have, I think, Sunnyvale, California, Westford, Massachusetts, Bangalore, India. Yeah, obviously, ultimately, working on bleeding edge stuff to think about, what's happening, whether it's, where quantum is going, what's happening with 6G, whatever's coming next. Talk about Juniper Beyond Labs. Talk about a little bit of how that all works ultimately to build this and maintain this amazing ecosystem.
That's a very good question. So, there was a time in this country, there used to be very innovative research labs like Bell Labs or IBM Watson Labs, Xerox Spark, Mouse came out of that, we benefited from. That sort of investment is no longer practical. A lot of companies are not able to do that. At the same time, there's a need to look ahead where the industry will go and still be able to invest in it. So this Juniper Beyond Labs, an initiative we started, basically it's an umbrella across the company to see how can we invest in innovation and pathfinding. That is still practical. It will lead to some practical things, but we can make some bets. Make them some bets in a way that you can early on decide whether those bets are going to pan out or not, and decide whether to invest more or not. So that's where I mentioned this idea of pathfinding incubation came. You start with the big funnel of ideas, start narrowing them down through pathfinding, proof of concepts kind of exercises. Some of them have promise, then start incubating their software products, like a RAN intelligence controller as an operating system I mentioned, and finally take them to the market. And we have been doing it across the company in the areas I mentioned, those 4 pillars. And that's the kind of investment we can afford. We also started as part of that university research program. So we fund research in universities. And why? Because that way there are no strings attached. They develop their own research, their thing, but they collaborate with us. So those ideas can come in, right? And we can hire those engineers, students who come in, graduate with master's, PhD as engineers, and that's other effort. And third one is partnerships and collaboration with other companies, larger companies. So we developed collaboration with companies like IBM Red Hat, right? We are collaborating with Intel because they have a lot of interest in 5G with respect to bringing open ecosystem innovation. So Juniper Beyond Labs has these multiple aspects to be able to partner with customers, partner with other companies, partner with universities, but more importantly, invest internally for fast fail kind of things. So I use a term called minimum viable demo, not a minimum viable product. Typically, if a startup is working on something, they develop something called minimum viable product that they can start selling to the customers. Minimum viable demo concept I came up with is similar to that in the sense that it's a demo, it's not a product, but it's not a science fair demo or a throwaway demo. It's a thing we build that we can hand over to the customers. It's robust enough for a customer to try it and give us feedback. So it's neither MVP, neither a demo that you just do it kiosk in a particular conference and move on. It's somewhere in between.
And you mentioned obviously your collaborations with industry and academia in that case. What about, clearly, I mean, again, I refer to what you do as sort of the bleeding edge, and obviously, you look for the best of the best through these academic relationships because we have to nurture that next generation that's coming along. As a country, are we doing enough in this space? What else could we be doing in terms of, getting that next generation up to speed on these areas, whether it's the AI, the machine learning, the quantum, which is clearly, one of those frontier areas you mentioned, whether it's 5 years or 15 or whatever the case may be, it's clearly, an area that we can't afford to get wrong. Let's put it that way for the future of our industry. What? Just give me your broad spectrum thoughts on sort of the importance of nurturing that next generation of thought leaders, specifically to focus on these bleeding edge areas.
Leadership inside Juniper or across the industry, what we do with respect to innovation and leadership, that edge that United States has, how do we continue to maintain? Which one? I just want to make sure that is the right question.
Definitely both.
Both, okay.
If you can address them both.
Okay, so let me start with the second one and go to the first one, because the second one I'm very passionate about. I do believe that the system of innovation that US has created is long lasting, right? For the following reason: the startup ecosystem and this concept of venture funding fuels innovation even in universities and academia. I used to be a professor long time back. That time in academia, professors gave away whatever they did. It went into open source movement. It went into different kinds of open systems. But nowadays the professors, even in the middle of the country, think about the innovations and how to commercialize them using venture funding. Right. So reason you get OpenAI kind of innovation, which is just a revolution, right? What is happening with generative AI revolution, those kind of things are happening either in big companies because they are investing in innovation, but they're also happening in universities which get funding from funding agencies, but they're looking at it also to take it to the market. So I think that sort of a close feedback loop where you have some initial funding coming from the government or industry to do the research in universities, which leads to some venture funding and the innovations come out, is a great way to continue to innovate in my opinion. What is important is that the government continues to fund research in academia through National Science Foundation, from Defense Advanced Research Projects Agency, Homeland Security. There are different mechanisms. That has to continue in my opinion, because that's a much better system than any other country has been able to replicate in my opinion. The second part you said, how do we nurture leadership in the company like Juniper? And this is where I think what we have done internally is that we have, for example, we have a Juniper Spark annual conference. Internally run like a research conference in academia. We have people required to submit abstracts of the papers or posters or demos of new work they're doing. This could be 2-3 engineers getting together and doing something outside of their main job or part of their main job. So the conference becomes a way to each other to exchange ideas, demonstrate things, so we can, and we give prizes, rewards, we connect them to the right marketing or product management resources, so those ideas can be taken further and so on. So that's one way. The second one is have a very strong mentorship program. So inside we have something called Juniper Career Connect. It's a portal in which you can go and sign up to be a mentor or mentee. You can sign up for what we call gigs. What's a gig? They advertise a gig where they say, here's an idea that somebody could work on it during the weekend, the free time, whatever they want to, 2-3 people, and advertise the gig. Somebody matches with the gig their interests. Why do they want to do the gig? Suppose they're today working on platform validation, but they're looking at all these generative AI, open AI, ML, and they think, I'm missing out in my career because I'm not working on those things. The gig is a way to give them an opportunity to work on some new things. So I might post a gig saying that, can you apply generative AI to create a better demand generation emails for marketing? And somebody signs up for that gig, he has to learn new tools like from OpenAI or other open source models and apply that. As a part of doing the gig, they develop new skills and now they can try to take their career in a new direction. Move into an area where they can start applying generative AI. They might move out of their team to another team where they can apply those skills better. So that's another way to start nurturing next generation leadership in my opinion.
Raj, I follow you on social media, and at the beginning of the year, you gave Raj Yavatkar technology trends and predictions for 2024, and of course, you mentioned things like obviously Gen AI is here. Obviously very cool technology. We got to think about security of Gen AI, as you mentioned, cloud edge computing, sustainability, as you talked about, and of course, the role of quantum crypto and security and the issues there. You also talked about some sort of hype and sort of non-trend issues, but we'll put those on the side for now. Clearly, you hit everything on the head, but we're only halfway through 2024. Anything else in terms of trends, topics, innovations, while we have you with us today, that have come up since the beginning of 2024 that you want to mention while we have you today? Please take the floor.
Sure. I think one thing about these predictions, every year I watch them, including mine, and they're more often wrong than right because we always get surprised by the end of the year where the year ended up, right? So you have to be humble about these predictions. You think you have a crystal ball, but you don't. So what I've seen in terms of changes by the middle of this year is that, Gen AI, it's just moving on very fast and all, nobody can doubt that. But one of the things I'm also noticing that people are not paying attention is optics,
Okay.
right? And because the networks is rapidly evolving in terms of amount of bandwidth you have to support these machine learning things, the innovations happening in the optical domain, including optical switching, which I think are going to happen, just like quantum computing, they happen faster than we expect. So the way people are building networks, large data centers, fabrics, might be changing faster than we think. That's one thing I will observe from what I've seen. The second part, I think we always underestimate the impact on security of new technologies. And I'm beginning to see that generative AI, not just deep fakes and impacting elections, all that stuff, but they're generating more kinds of attacks, attack vectors that we can't even imagine. They're completely generated by machine learning. And they are able to explore the search space for attack vectors in a way that human beings cannot. And that's going to be a bigger threat than we anticipate, in my opinion.
Well, it's going to be an interesting coming decade with regard to all these tools. And, again, it's been quite a fascinating path that you've been on, that Juniper's been on. And again, for a company that's kind of, quiet and behind the scenes, clearly working, as you point out, on extremely important issues, this Pathfinder strategy that you talk about, and really, really fascinating work. I look forward to continue to follow you and the company, and just wishing you and your team, and of course the whole group of Juniper Beyond Labs, the best as you continue to develop these technologies that make all these systems run better and more efficiently and more sustainable. So really, really great stuff, Raj. Again, for everybody that's going to be listening to this particular episode of the show across the various podcast networks, or watching on our YouTube channel, again, you've been spending time with Dr. Raj Yavatkar, Chief Technology Officer, Juniper Networks. Raj, again, thank you so much for taking the time out of your schedule to come talk to us, come educate us on some of these themes that we don't normally talk about on the show. Obviously, thank you for everything you do for the advancement and innovation in the technology space. And as we like to say on our show, thanks for creating a better tomorrow via the type of work you're doing. Really a great story, and it was great having you here today.
Thank you, and thank you for having me.